thank you very much, Paul, and to Gencom and to Belfast Met for inviting me to speak here today. I am looking forward to it, and apologies for the earlier interruption. So my name is James Burchill. I'm currently head of Asset Operations in Gas Networks Ireland. For those of you who will be unfamiliar with the gas network in Ireland, we're the state-owned utility responsible for the transportation of natural gas. So we manage the gas transportation and distribution system in the Republic of Ireland, but we also operate assets in Scotland, Northern Ireland, and on the Isle of Man. In the slide, you can see the role that natural gas plays in meeting the energy needs of the country, with on average 54% of electricity generated on any given day by natural gas. However, that is only an average, and in certain conditions that can reach up to 80% or more. You can secondly see the importance that natural gas serves to industry and into meeting the domestic heat loads. While the title of this presentation, Hydrogen Injection into the Grid, a Challenge, I think it could also be seen as a real opportunity. So, as important as natural gas is to our economy, we as transporters absolutely recognise that there is a requirement to decarbonise the grid. And just as other system operators across Europe have done, Gas Network Ireland has set out a roadmap to do this in our 2050 document, which is available on our website. One of the key enablers to that pathway is the introduction of hydrogen onto the grid. As you can see in the diagram, the gas grid is instrumental in providing that vital link between end users and producers. And in addition to being the most effective way and efficient way of transporting hydrogen, the grid offers the advantage of being able to provide long-term energy storage. Just by example, the current energy storage held in the grid at the moment is about 620 gigawatt hours of energy. So while the introduction of hydrogen poses many challenges, it also provides a great opportunity for producers, shippers, as the grid offers the opportunity not only to displace the current role natural gas has in heat generation, but also offers the potential to gain the share of that 48% of primary energy demand currently held by oil and predominantly in the transport sector. And I note that during the week that the first hydrogen-powered train made its maiden voyage on the UK rail network. To safely introduce hydrogen into the existing grid requires the coordination of a great number of activities. One of the very first things, and I have to say I was instrumental in this, being an engineer, is that we have to get our hands dirty and get a feel for how hydrogen and hydrogen blends behave on the system. And to that end, we're constructing a small-scale test facility at our campus just outside Dublin. This facility will replicate the existing distribution grid and typical downstream appliances found in our homes. Key to allow us to transport hydrogen in any concentration is the acceptance by the regulatory authorities of a safety case. We must prove beyond any doubt that the transportation of hydrogen, the risks associated with it, are as low as reasonably practical. In other words, we must be able to prove that the transportation of hydrogen or hydrogen blends is as safe as the transportation of natural gas. To achieve this requires a deep knowledge and understanding of the technical challenges associated with hydrogen from both a material and gas characteristics perspective. This is not a journey we can undertake on our own, and we will need to rely on experts from many areas, but also build on the work which is going on across Europe on the development of technical standards and specifications in this area. And finally, in order to allow gas to flow on the network, we must put in place the market arrangements to allow shippers to transport gas in a fair and equitable way. So I'm going to delve in to look at some of the technical practicalities around the injection of hydrogen into networks. And I have to say at the commencement of this is the commencement of a journey. All across Europe and the world, grid operators are trying to get to grips with these issues. In the UK's National Grid are hoping to construct a replica of their transmission system at Spade Adam near Newcastle. However, on the positive side, we know that hydrogen pipelines can be constructed and they do exist. What we need to establish is if the current natural gas infrastructure can be adopted to transport hydrogen and can be as safe as the existing network. Currently, all the evidence coming from Europe, particularly from the work undertaken by Marco Gas, is that hydrogen at low concentrations, 2% or so, does not pose a problem for high-pressure steel transmission mains. This leads on to what is an optimum blend and blends versus pure hydrogen. Where I think we're going with this, and this is only my opinion, that two scenarios are likely to happen before we see the build out of a full hydrogen grid. Certainly, we're going to see local hydrogen production from renewable wind sources looking to inject locally. Second possibility, and one envisaged in the UK, is the large-scale production via SMR and carbon capture, which will feed a local industrial cluster with pure hydrogen, but will again inject excess into the local grid. Either way, it's clear that as a transporter, we need to be prepared for a period where blends of hydrogen and natural gas and biogas coexist on parts of our network. And then the question begs, what blend? What is the optimum blend? And at the moment, the consensus seems to be landing on 20% or so, based on the ability of downstream appliances to. So, as transporters, we need to understand what the effect of a 20% blend and ultimately pure hydrogen will have on steel pipelines, and in particular some of the older grades things. So moving then to the distribution system, that is the lower pressure in the grid, which supplies the vast majority of end users. The picture here is encouraging, as Ireland has the most modern network in Europe, being entirely of polyethylene. So we do not, as in other jurisdictions, need to deal with legacy cast iron, asbestos, or other materials which were used in former times. Thus far, all research and studies indicate that polyethylene is fully compatible with the transportation of hydrogen. Nevertheless, we do need to understand a number of issues, not least of which is how to safely manage leakage events on the network. So, for example, what is the profile of gas dispersed in the event of a third-party dig? Where can we safely position our repair crews? What are the exclusions required for the general public? In our test facility above under construction, the valving arrangements shown will allow us to insert pipes and fittings with known defects and compare the results between pure hydrogen, hydrogen blends, and natural gas to see how leakage and other aspects perform. Finally, the other subject there's a lot of research in, and we will also need to investigate, is the area of metering. We absolutely necessarily need to ensure that our customers are billed for the energy they receive. This leads on to market arrangements. So in the slide above, I've some open questions that market arrangements will need to address. In the current markets, shippers nominate their daily quantity of gas they want to bring into the grid, and they balance that by day end. These arrangements work well because there are no practical constraints on the availability of natural gas. And secondly, natural gas is essentially homogeneous. So as a source, be it the North Sea, Corrib, or biomethane, it's interchangeable. It's still one molecule. The challenge then will come about how to manage gas with differing parameters, such as blends of natural gas and hydrogen. The question is, how do we maintain a blend that is uniform or in the network or part of the network, while managing the very real commercial requirements for producers and shippers to bring their products to the end users? Certainly, the solution will be storage, and in all likelihood, greater control systems will be needed to manage the blends across the network to ensure that the capacity is managed optimally and that the quality is maintained. These are issues that the industry in large will need to put rules in place via the Code of Operations to manage. But I will say that we have as we manage odorant across the network and manage odorant blends consistently across the network, it is possible to do this. It's just what market arrangements are we going to put in place to allow us to keep the consistency in the grid. Finally, in this section, I'd like to look at briefly some of the downstream aspects. So while domestic appliances built or designed and built after 1996 are theoretically capable of blends of taking 25% or more of hydrogen, in our test facility, we're going to look at the actual performance of these domestic appliances with varying blends and the effect of things like pressure fluctuations leading to incomplete combustion and water vapor production. We're also going to look at calorific value, metering accuracy, flame pictures, and we're also looking then to look at areas or to look at the effect on pre-1996 appliances, because we know that these are also out on the network. We're ready to get into these. We're actually about to get into this area of research with some academic partners. Unfortunately, however, we've been slowed up by the COVID situation, but we hope to be up and running fairly soon. So that concludes my short overview of some of the challenges of bringing hydrogen onto the grid. It's no means comprehensive, it's just starting to surface. As I say, we're on a journey here, and no doubt we'll be looking to rely on experts, as I say, out there to assist us as we progress. So thank you. Whirlwind tour.
We'll take a couple of questions.
Sure.
We've stimulated a lot of debate, a lot of questions coming in. We mightn't have time for them all, but what we will do, folks, as in previous webinars, any questions we don't get to, we get them to the relevant presenter, and we then to go back with questions if we put them in the GenCom website. First thing I'll ask you, James, is you went through all the different aspects of it there, and I'm going to give you a quote from the UK Environmental Audit Chairman, Philip Dunn MP. 2 months ago, he said, as we near our commitment of net zero carbon emissions by 2050, we must consider all options to generate energy that does not harm the environment. Hydrogen could be part of the solution, but it must be produced, stored, and used in ways that do not create harmful emissions and maintain the highest safety standards. Can you quote on that, given the presentation you gave with the slide with the 5 chapters in it, please?
I mean, he's right. I mean, the opportunities for hydrogen are immense, and I think I was lucky to be in a conference in Europe, or in a virtual conference in Europe yesterday, and there is a huge drive for it. Everybody loves it. We do need to understand how we can safely transport it in the existing grids. A lot of work is going on board all across Europe, and it can be done safely. It's just building on the various aspects of research around Europe to pull that together and so that we can move together in tandem with it to allow it onto the network.
Excellent. Question from Tom Murphy is: can lessons be learned from the conversion of coal tar gas to natural gas be applied to the conversion to a hydrogen network?
Very much so.
That's an easy one for you, James.
Very much so. So yes, I mean, people will maybe remember and up until recently in Belfast, Towns gas was in common usage, and it was made from coal. That contained almost up to 50% hydrogen. Carbon monoxide was the other main component of it. So yes, it's very similar to the challenges faced previously in converting from coal gas to natural gas. There will be different challenges. Natural gas was much drier and caused a lot of problems with some of the materials, but no doubt hydrogen will bring its own challenges. But yes, it's very much, and the actual conversion process we would envisage to be very, very similar in terms of sectorizing the network, bringing areas along, and then doing that appliance conversion. So yes.
Before we go to the next question, James, you talked about you're at the commencement of a journey and hydrogen is a key enabler. Do you see the transfer to hydrogen as evolution or revolution?
It's going to be a revolution for the industry to readapt, but it is evolution in terms of we as a grid need to move with the rest of the world in decarbonising. I think for the people who are going to be to do that conversion, and like the previous question, that coal tar, it's going to be a revolution. It's going to be a whole different way of thinking, embracing a whole new technology and a whole new set of challenges. But it is only the evolution of the grid. You know, we've gone from coal manufactured gas to natural gas, and the next step will be hydrogen.
And one final question from our colleague in Hydrogen Mobility Ireland is from Maeve Connolly. If we focus on blending hydrogen in existing gas grid rather than a dedicated supply of hydrogen for use in the hard-to-abate energy sectors, are we at risk of displacing some energy users from alternative, more energy efficient decarbonisation options such as heat pumps or residential?
Say that one again to me, Paul.
Maeve wants to know, if we focus just on hydrogen, are we going to miss out on some of the other hard-to-abate sectors such as heat pumps or residential to decarbonise those options?
No, I mean I think we set out in our Vision 2050. You know, hydrogen is only one element of our vision to decarbonise.